So good evening. Let's start with the DIT-FFT. In the DIT-FFT, what happens is that our input it is in the normal order and our output it is in the reverse order. Okay. Then another important change is that first we do the higher order DFT and then we go for the lower order DFT. So apart from this, there is another basic change in the architecture. And if you look into the 2 FFT, so in our DIT-FFT, our dual factor it was just beside your beside the starting of this butterfly architecture. However, in the DIT-FFT, your total factor multiplication is after this butterfly intersection or this transfer of the values. Okay. So similarly over here, if you see in the 4 this DFT or FFT, we have this W04 and W14. After there is an exchange of the information, okay, and just like in the DIT-FFT, the total factor values they are below the line of symmetries. Okay, so this is the only change. So similarly in DIT-FFT, if you see the same thing happens. So this is the line of symmetry which divides the number of inputs in two equal parts, and in the lower parts there will be a multiplier of 1. So there is a printing mistake from where I have taken this architecture. Okay, so there will be a -1 multiplier, and again from say upper one to lower one there is a transfer of signal component and vice versa from lower one to upper one. Okay, and in the lower portions we are having this total factor multipliers. Okay, so the tabulation thing over here. Now if you see our input it is in the normal order and our output it is in the reverse order, bit reverse order. So so why we want to go to FFT? We want to go to FFT because in DFT we have complex multiplications of n square and complex addition it is of this n into n minus 1. Okay, whereas in the radix 2 FFT we have the complex multiplication of n by 2 log 2n and complex addition of n log 2n. Now while performing IDFT, we can perform IDFT in two methods. So IDFT 1 and IDFT 2. In the IDFT 1, what we have, there would be two methods. We are having DIT-FFT method we can use, and we can also use the DIT-FFT. So XK will be used as the input for both the DIT-FFT and IDFT butterfly architecture. Okay, and we said that even the name is name over here is DIT-FFT. So what will happen? The input or this input which is in the frequency domain, it would be in the reverse order in the DIT-FFT. Okay, while we are computing the IDFT. Okay, even though we are using the frequency component, the input to the DIT-FFT architecture it would be in the reverse order. Okay, so in general what we discussed in DIT-FFT method, if you want to calculate the forward transform, so input should be in the reverse order. DIT-FFT input should be in the reverse order and output should be in the normal order, right? So it was in the time domain. Okay, And all these transforms, they have been designed to work with the time domain signal. Even though when we are going for the IDFT, so what is happening? The architecture, it remains the same. So we will name it as DIT-FFT. IDFT, compute IDFT by DIT-FFT method. The algorithm over there, it will be remaining as decimation in time FFT. But what you are using? You are using the XK component or the frequency component for computing the IDFT. Are you getting my point? So, what is the main thing? The main thing is that input will be in the reverse order. Even though you are using DIT-FFT for computing the IDFT, so the input would be in the reverse order and our output would be in the normal order. In the case of DIF-FFT, input would be in the normal order and output would be in the reverse order. Okay, then this would be your first step. The second step would be conjugate of Tudor factor would be used. Okay, and the third is xn as output. In DIF-FFT, our output is in the reverse order, and our in the DIT-FFT algorithm we have output as the normal order. Okay, in the second method for computing IDFT, so we have to take the conjugate of x of k. Okay, first. The second is we have to perform the Fourier transform either with the DIF-FFT or with the DIT-FFT method, whatever suits us. Then we will be getting x dash conjugate n. Okay, then again we have to take the conjugate of x dash n. Okay, and lastly we have to compute xn by 1 by n multiplied by x dash n. Okay, so what is the difference over here? The difference over here is that we have to take 2 times conjugate. Okay, first we have to convert the frequency domain signal into the into its conjugate. Then once we get the x dash conjugate n, again we have to take the conjugate to get the x dash n, to which we will be multiplying with 1 by capital N. Okay, so over here we have to take 2 times conjugate. Okay, on the other hand, if you look into the first method, over here if we take the conjugate of the Tudor factor, it will be capable, or you will be able to eliminate one step. Okay, so in that way it will be easier for you to do the computation. You can do the computation in using either of the methods, but I prefer the first method, but it is up to you whether you want to go for IDFT1 or IDFT2 method. Okay. So let us see the example. We have looked into this example, I suppose, in our last class. So calculate 4-point DFT using the DIT method. We computed that, and then again we looked into how we can go for the computation of the IDFT by the DIT-FFT method. Okay. So I will not go into the things as of now. So what you can do today is that, because these two things, they are a bit confusing, so I would like you to compute this 4-point DFT both by DIT-FFT method and DIF-FFT method, and once you go get into this frequency domain, again perform the IDFT. Okay, again perform the IDFT by both DIT-FFT method and DIF-FFT method. The reason being, from the next class onwards, we will be going into convolution. So we will be looking into the convolution in both time domain and frequency domain aspects. So before we get into this convolution, I want you that you have a proper understanding of these two methods. So compute FFT by both DIT-FFT and DIF-FFT method and its inverse transforms. Okay.